Hi-de-ho, Renaissanceteers, and welcome to another meeting of the minds of La Société Renaissance. Today I have a very special puzzle for you. In fact, it's so special I thought it deserved a video. This puzzle was suggested by my cousin Kurt, and it's a structural design problem. I'll tell you about the puzzle in just a moment, but first, by way of introduction, I'd like to talk a little bit about triangles. Well, what's so special about triangles, you might ask yourself? Well, triangles are very special. Triangles, as their name indicates, have 3 angles, and they are so special that they have a whole branch of mathematics dedicated to them called trigonometry. Trigonometry comes from the Greek, meaning triangle measurement. Have you ever heard of pentagonometry, or hexagonometry, or any other polygonometry? No, it's because they don't exist. Only triangles get their own special branch of mathematics. And why is that? Well, let's compare triangles to quadrangles. Here we have a triangle, and this is made out of drinking straws chained together with a piece of thread. There's no glue at the joints, and yet here it is. It holds its shape perfectly well. I can press on it. It doesn't want to deform. Now, let's take a look at a quadrangle. Here is a quadrangle, has 4 angles, and if I release it, it flops around, has no rigidity at all. It needs to be braced. And how do you brace it? With triangles, of course.
Triangular braces are used everywhere. Here you see an example of a warehouse under construction, and the steel frame is reinforced with triangles to keep it from collapsing like we saw with our drinking straw quadrangle. And here is a crane. You can see that there are lots of triangular braces reinforcing both the tower and the boom. The boom looks curved in this picture because this is a stitch of several photographs. Here's a photo of our indoor tennis court, and you can see that even though it has these massive laminated beams supporting the roof, they're reinforced with little triangular bracing cables to keep it from collapsing, just as we've seen at the steel warehouse. And check this out. If you use opposing braces, they don't even have to be rigid. In this case, they're using cables. So one cable keeps the building from collapsing in one direction, and the other cable keeps it from collapsing in the other. You can see a detail of the cable construction on the left there. So here is your challenge for Renaissance puzzle number 45. Imagine that you have an unlimited supply of rods, all of the same length. They can only be connected at the ends. Your task is to construct a rigid square by connecting as many rods as you need to brace it. Furthermore, you are confined to a plane. The square and all braces must lie flat, with no rods crossing over each other or sticking up in the air. If you were allowed to add braces in 3 dimensions, the job would be easier. Here is one example of how it could be done. Here we have a quadrangle made out of 4 toothpicks that are glued together with hot melt glue. Now, hot melt glue is rubbery, so you can flex these joints, and this gives us a chance to test the rigidity of our figures. Now, we already know that a quadrangle is not rigid, so how can we reinforce it? Well, we know that triangles are rigid, so maybe we can fix some triangles to it somehow. Well, one way we could do that would be to build a pyramid. So here we have 4 triangles joined together at the peak to form a pyramid. And you might think that looks pretty strong, but let's test. We'll press here, and look. We press these 2 corners in, and the other 2 free corners lift up in the air. Well, that gives us an idea. Suppose we take 2 pyramids, and we join them together, like this. Then, you see when we push on them, they still open up at the center, but if we secure them at those free corners, and in fact, instead of having 2 toothpicks here, we replace it with 1, we'll make a new figure. So that's what I've done here. I've created the single figure with 2 pyramids joined together. I've colored the toothpicks now, so let's imagine that the red toothpicks are the common base of the 2 pyramids. And this figure is called an octahedron. That's because we have on the top side 4 faces. Hedron means face in Greek. And on the bottom side we have 4 more faces. So 8 altogether is an octahedron. Now the interesting thing about this is if I hadn't colored the toothpicks, it would be difficult to remember where the base of the pyramids are, because this figure looks the same regardless of which corner you stare at. Here we see a red square. I turn it at an angle and now we see a green square. And I turn it at another angle and now we see the uncolored toothpick square. So it's we've lost our orientation in terms of 2 pyramids, and we have this very strong structure called an octahedron. I can press on this until the toothpicks actually start to bulge, and it does not want to change its shape. It's a very rigid structure. So, well, enough about our 3-dimensional figures. We've got to get back to our Renaissance problem number 45. So remember, you are confined to a plane. The square and all braces must lie flat with no rods crossing over each other or sticking up in the air. All rods must be exactly the same length. So this picture is not a solution because the red rod is longer than the blue rods. All rods must join at the ends. And so this picture is not a solution because the red rod is not connected to the ends of the blue rods. And of course, you must form a perfect square that is braced such that it cannot be deformed. This is not a solution because the blue square is not rigidly braced. So be aware there are many solutions to this problem using various numbers of rods. Because this is a more challenging puzzle than most, any valid solution will be awarded 2 Renaissance points. If you find a solution that uses less than 30 rods, you will receive a bonus point for a whopping 3 points, the highest value thus far for a single puzzle question.
And so, Renaissanceteers, I wish you all good luck and Godspeed in solving this puzzle. And I hope you will have learned that triangles are just the thing you need.